Hi students, how are you? All seniors might have successfully completed your IB exams. So get ready for forthcoming objective tests. Second session of mains, MSET, neet and advance. Okay. So all the best once again. So in this video I would like to explain how to find time period in various situations. Already we come across some situations but still we left with some more situations. What is that? See here, simple pendulum. Oscillations of simple pendulum, not in air, but in the liquid column. See, already we completed oscillations of simple pendulum in air or vacuum. What is the expression? T equal 2 pi root over L by G. But here it is not that case, but bob of the pendulum is going to oscillate in the liquid column as shown, not in the air column. See, this is the rigid support from which a pendulum bob is suspended by means of inextensible light string usual. So when it is pulled aside and left to itself inside the liquid column, so it is going to oscillate like this. See, this is going to oscillate inside the liquid column action. See, all these dots are nothing but the liquid column, liquid. Right? What is the density of liquid? Rho M is the density of liquid. What is the mass of the bob here? M. So that's why it is acted upon by gravity mg downwards. Mg downwards. Now at this instant, what is the angle made by the string here? Theta. So as bob is oscillating inside the liquid column, it is acted upon by one additional force in addition to gravity. What is that force? Force of buoyancy. So here see, this bob displaces some portion of liquid, right? So because of that displaced liquid, that liquid exerts some force upthrust on the bob here. That's what usually known as force of buoyancy, otherwise buoyant force. So what is the direction of force of buoyancy? Always opposite to the weight. So that's why upwards. So this bob, as it is oscillating inside the liquid column, it is acted upon by force of buoyancy, that is FB. FB. Force of buoyancy. What is the expression for force of buoyancy? How to measure force of buoyancy? See, force of buoyancy numerically equal to weight of the liquid displaced by the bob. That is weight of the liquid displaced. That is mass of the liquid displaced into G. ml means mass of the liquid displaced by the bob. Right? So that is equal to mass of the liquid displaced, not entire liquid. Whatever the mass of the liquid displaced by the bob, that is to be taken here. Mass means usually mass equal volume multiplied by density. So volume of the liquid displaced by the bob into density of the liquid into G. See here, VL is the volume of the liquid displaced. Usually that is equal to same as the bob here. Why? Because bob is completely immersed inside the liquid. That's why VL usually equal to volume of the bob also here in this case. So what is FB here? VL rho LG. Here rho L means density of liquid. VL means volume of the liquid displaced, otherwise volume of the bob here, into G, acceleration due to gravity. So here, what is the net vertical, net downward force acting on the bob means mg minus FB. That is the net downward force. If FB is not there, if FB is absent, then mg only net downward force. But it is acted upon by force of buoyancy upwards also. That's why what is the net downward force here? mg minus FB. That is VL rho LG. VL rho LG. This is the net downward force. See here. Now, what is the displacement of this bob from the main position? See, this is what x. X is the displacement of the bob, that is away from the main position. Now, which force causes the bob to get back to its position? What is that force? Restoring force. What is the restoring force here? Means if this net force is resolved into two components, that is, one is opposite to displacement, another one is perpendicular to displacement line. See here, if here it is theta, here also theta. See, this is what? Theta. If I extend this line like this, theta is the angle here, theta. So here also theta here. So therefore Therefore, if Mj minus VL rho Lg is resolved into two mutually perpendicular components, this is cos component, that is Mj minus VL rho Lg into cos theta. So this is what sine component, that is Mj minus VL rho Lg into sine theta. See the direction of this sine component opposite to displacement. Why? Because displacement is like this x, but Mj minus VL rho Lg sine theta opposite to displacement. So that's why this must be equal to restoring force. So in these two components, this component is see the direction of this component is towards mean position. See here, this is the mean position, x equal 0. See the direction of this force that is acting towards the mean position. Therefore, this must be the restoring force, which causes the bob to get back to its position, previous position. That's why F restoring equal to minus, as it is restoring, we have to consider with the negative sign, minus Mj minus, see here, Mj minus VL rho Lg sin theta. That is Mj minus VL rho Lg whole into sin theta. Right? So for small theta, if it is under small oscillations, then sin theta almost equal to theta. That's why minus Mg minus VL rho Lg into theta approximately equal to theta. So what is F for restoring force? Usually equal to minus K into X minus K into displacement. That is minus cancel here. So minus cancel, we left with K into X equal to M is kept common here, that is M of G minus VL rho L G into theta. See here, as theta is very small, sin theta almost equal to theta, but also equal to tan theta. So sin theta equal to, see here, sin theta almost equal to theta, but also equal to tan theta. So that equal to sin theta equal to theta almost equal to tan theta. That is opposite side by hypotenuse. Adjacent. What is this adjacent side? L. Length of the pendulum. That is x by L. So theta equal to x by L. That equal to x by L. So theta equal to x by L. So x by L. So therefore x cancel. We left with the k equal to m of g minus. See here, when m is kept outside, here VL rho Lg by m. So therefore k equal to m of g minus VL rho Lg by m whole into 1 by L. Right? Now what is k? K equal to m times omega square. We know that k equal to m times omega square equal to m of g minus VL rho L g by m whole by L. That equal to whole by L. Now mm cancel. We left with omega square equal to g minus VL rho Lg by m whole divided by L. Now omega equal to, that is 2 pi by t. We know that omega equal to 2 pi by t. That equal to, here it is square. If omega is make it subject, omega equal root over g minus VL rho L into g by m whole by L under root. Okay. Now what is t? Period of oscillation. T equal to 2 pi into root over L by g minus VL rho L g by m. So this is the ultimate expression. That is, period of oscillation of pendulum inside a liquid column is given by 2 pi root over, it's not L by g but root over L by g minus VL rho L g by m. Right? So that is how one can find period of oscillation of pendulum in case of when it is oscillating inside liquid column. So here we followed some steps. First of all, to find mean position from which it is displaced through some distance, right? From which to take restoring force and is to be equated to minus kx, etc. These are the steps already we came across in previous lecture, right? Okay, next case, that is, in next case, oscillations of liquid inside tube, U-shaped tube here. Liquid, oscillations of liquid in U-tube, U-shaped tube here, U-shaped tube, right? Oscillations of liquid. See, so have to consider one U-shaped device with the two limbs, each of cross section capital A as shown in the diagram, right? So that's what I'm going to write here. Okay, see, this is what one U-shaped device like this with the two vertical limbs, each of area cross section A. So this is what A. This is also A. Each of cross section A. See, this is what left vertical limb. This is right vertical limb. Each of cross section A. Now this is filled up to this level. So this is what equilibrium level. Equilibrium position, right? That is y equal to 0 is the equilibrium position of the liquid. So it is filled with liquid up to this level, right? Now what is the mass of the liquid here? Let be m. M is the mass of the liquid, right? So this is what liquid like this. Okay, up to here. Okay, this is what equilibrium position, otherwise main position. That's what to assign equilibrium position of the given body. That's our first step in finding time period. Now what is the second step? The body is to be pulled aside and left to itself to make oscillations. So here liquid in either left limb, otherwise right limb, is to be compressed. For example, it is pressed down like this up to here, for example, through an amount, through a distance y. So this is the compression in the left limb. So liquid in the left limb is compressed through a distance y. So thereby what happens? The liquid in the left limb pushes the liquid in the horizontal portion rightwards, which in turn pushes up the liquid in the right limb. So therefore naturally this liquid in this right limb goes up to this level. What is that level? Again y on, again y, vertical upwards, vertically upwards. See y, again y. So this is also y. So this is what the compression in the left limb. This is what the raise in the raise of liquid level in the right limb. So usually these two are of same amount. That is y plus y. Now what is the y plus y? That is 2y is said to be unbalanced liquid head. So y plus y equal to 2y is said to be unbalanced liquid head. Unbalanced liquid head. Because of this unbalanced liquid head, that is y plus y, 2y, exert some restoring force on the remaining part of the liquid, so that it gets back to its previous position, right? Therefore, so because of that reason, it reaches to its main position, and because of inertia it shoots up into other side, but because of restoring force again comes back to previous position. Because of inertia shoots into another side, so the process continues for a while. So in either limbs, liquid gets oscillations like liquid gets oscillation. So get into oscillations like that. So here also it goes under oscillation like this, right? Why? Through a pressure through an unbalanced liquid head 2y, right? So here 2y means unbalanced liquid head causes restoring force on the remaining portion of the liquid, right? So what is the unbalanced force here? So F restoring equal to minus of unbalanced force caused by liquid head, right? That is Fr equal to minus. What is the unbalanced force caused by liquid head here? That equal to usually force equal pressure into area. That is pressure into area. Pressure into area. That is pressure means we know that H rho G. H into rho into G into area. Pressure means H rho G. H means what here? Unbalanced liquid head. That is Y plus Y. H means H equal to Y plus Y. That is 2Y. So H means what? 2Y minus 2Y into rho means rho L. Rho means rho L. Rho L into G into area. What is the density of liquid here? Mass M density rho L, for example. Density of liquid. Okay. Now restoring force usually can be represented by minus K into X, otherwise minus K into Y, as per the symbol taken here. Here we have taken Y, not X. Why? Because liquid is going to oscillate along vertical direction, either upwards or downwards. That's why it's not minus K into X, that is KY. So YY gets cancelled, minus minus also cancel. We left with K equal to 2 rho LG into A. But K is what? M omega square. M omega square equal to 2 rho L G A. Now omega means omega equal to 2 rho L G A by M under square root. Right? That is omega equal to 2 pi by T, also equal to 2 pi by capital T. Now what is T here? T equal to 2 pi into root over mass of the liquid divided by 2 rho LGA. So this is the ultimate expression for period of oscillation of liquid in U-shaped tube. Okay, T equal to 2 pi into root over M by 2 rho LGA. Right? Now a small modification with the shape of the device. Here it is U-shaped tube, but if it is V-shaped tube, now what is the situation? Not U-shape but V-shape. A small modification. See here, U-shaped tube here. If I modify the shape of the tube as shown, then what should be the expression for period of oscillation of the liquid surface? Let us see. Right? V-shaped tube. See, this is what left limb. Now this is what right limb. Each of cross section A only, for example. So here it is A, here it is A. Not U shape but V shape. Now see, this is the initial level of the liquid as an example. Initial level. So liquid is taken up to this level in both limbs like that. Okay. Right. Now see, this is what horizontal. With the horizontal, what is the angle made by left limb? Let it be theta 1. With the same horizontal, what is the angle made by right limb? Let it be theta 2. So theta 1, theta 2. Now what is the first step to assign equilibrium position? See, this is what equilibrium position, right? Finding time period, this is the first step to assign equilibrium position of the level. That is main position of the liquid. Now what is the second step to be followed? That is, the body should be displaced through a small distance and left itself to make oscillation. So here, in either liquid in either left limb, otherwise right limb, is to be pushed down. For example, see, this is the level. See here, it is to be pushed like that. as an example, pushed like that. See, through a distance x as shown, through a distance x. Okay. Now, as liquid in the left limb down, pushed down, that is pushed along the limb, pushed down along the limb through a distance x. So, liquid in the left limb pushes the liquid in pushes up the liquid in the right limb. So, therefore, it goes up to here by the same amount, by the same amount here, right? So, if it is x, this one also x, this one also x. Okay. Right. Now, what is the angle here? See, if it is theta 1, this one also theta 1. If it is theta 2, this is also theta 2. Right? Now, liquid goes up to here. Here, liquid goes up to here. See, up to here. Right? Okay. Now, try to resolve x on both limbs. See here, x is resolved into two components. One is vertical component, another one is horizontal component. What is horizontal? X cos theta 1. What is vertical here? That is x cos x sin theta 2. Sorry, x sin theta 1. X sin theta 1. So x cos theta 1, x sin theta 1. Here also, x is to be resolved into two mutually perpendicular components. That is, one is x cos theta 2. Here it is up to here. See, vertical component x sin theta 2, x sin theta 2, x sin theta 2. So x cos theta 2, x sin theta 2. Here x cos theta 1, x sin theta 1. Right. So here, what is the unbalanced head of liquid here in the right limb? X sin theta. See here, from here to there, this is the extreme position of the liquid. It goes up, it raises up to this level. So what is the vertical component here? X sin theta 2. Usually that is what? Vertical component x sin theta 2 is nothing but unbalanced liquid head in the right limb. Now what is x sin theta 1 here? This is what? Unbalanced liquid head in the left limb. Now what is the total unbalanced liquid head in both limbs? That is vertical components. Here it is x sin theta 1 plus x sin theta 2. X sin theta 1 plus x sin. So h equal to in previous case y plus y 2y, but here it is x sin theta 1 plus x sin theta 2. So x sin theta 1 plus x sin theta 2, that is x of sin theta 1 plus sin theta 2. So this is what? H means what? Unbalanced okay, liquid head. So which causes remaining portion of the liquid to get back to its initial position. Therefore, so H is the unbalanced liquid. So implies that restoring force equal to unbalanced force caused by the liquid head. That is negative of, as it is restoring, negative of unbalanced force caused by the liquid head. So that is usual steps, minus pressure into area. That is minus H rho Lg into area. H means what here? H means x of sin theta 1 plus sin theta. That is a small modification here. Up to here, same steps. That is H means minus. H means x of sin theta 1 plus sin theta. X of sin theta 1 plus sin theta 2. X of sin theta 1 plus sin theta 2 into rho Lga. Rho Lga. Now what is Fr here? Minus k into x. If it is x, take x, otherwise y. So minus k into x. So x cancel, minus cancel. We left with k equal to, it's not 2 rho Lga, that is sin theta 1 plus sin theta 2 into rho Lga. Now what is k? M omega square. That is m omega square equal to sin theta 1 plus sin theta 2 whole into rho Lga. Now what is omega? That is root over sin theta 1 plus sin theta 2 whole into rho L G A whole divided by M. Now what is omega? Omega means 2 pi by T also. That is 2 pi by capital T. Now what is time period? It's not 2 by root over M by 2 rho G A, but equal to T equal to that is 2 pi into root over M by sin theta 1 plus sin theta 2 whole into rho L G A. So this is the ultimate expression. So 2 pi into, see here, 2 pi into root over M by sin theta 1 plus sin theta 2 of rho L G A. Of course, you can reduce the same situation to the previous case. What is that case? U-shaped device. If sin theta 1 equal 90, suppose if it is perpendicular like this, then theta 1 becomes 90. Right limb also perpendicular to itself, then theta 2 equal 90. So if I take theta 1 and theta 2 as 90 degrees, sin 90 plus sin 90, that is 2 rho G A. So the case will be reduced to the previous case, that is U-shaped oscillations of liquid inside U-shaped device, right? So that is about oscillations of liquid in V-shaped, not U, that is V-shaped here, V-shaped, right? Okay, so theta 1 is 90, this goes like this. Theta 2 is 90, this goes like, becomes V-shaped device becomes U-shaped device, U-shaped, right? So for theta 1 and theta 2, here theta 1, theta 2, if theta 1 equal to theta 2 equal to 90 degrees, then that equation becomes T equal to 2 pi into root over M by sin 90 plus sin 90, that is 1 plus 1, 2 rho L G A, right? So this is what period of oscillation of liquid inside U-shaped tube. This is for V-shaped tube. Okay, so that's about oscillation of liquid in U-shaped device and U-shaped tube and V-shaped tube, right? Now we left with one more case, that is oscillations of block floating body. Oscillations of floating body in the liquid. Oscillations of floating body, like see, floating body in the liquid. Oscillations of floating body, right? Now see, a block of mass m and area of cross section A is floating like this. See this what? A block of mass m, right? With area of cross section A is floating in the liquid as shown, such that some portion lying outside, some portion lying within the liquid as shown. That condition is said to be floating, right? Now what is the main position here? This is the main position. Now first step is over, next step. So it is to be depressed through a small amount like this. See here, same device is depressed like this, right? So this is the previous level, upper level, previous level of the top portion. Now this is depressed through a distance y like this. So definitely this is the previous level of the lower portion of the body. Now this amount also y amount. So here it is y, this is also y. Now this portion can be assigned as additional dipped portion of the body. See, this is what? Additional dipped portion of the body. Dipped portion, right? So whenever this body further dipped into the liquid and left to itself, now this dipped portion body, additional dipped portion body is acted upon by some band force which causes restoring force, on the body to get back to its previous position, but because of inertia motion, it crosses the main position and continuous oscillations on either side of the main position. So therefore, now what agent serves as restoring force here? Whenever this body is further dipped through small amount y, then this dipped portion will be acted upon by some bind force, right? That itself serves as restoring force. So therefore, F restoring equal to, in general, negative, that is force of buoyancy caused by force of buoyancy acting on the force of buoyancy acting on the additional dipped portion, additional dipped portion of the body caused by liquid, right? That is Fr equal minus. What is the expression for force of buoyancy? In general, this is what numerically equal to force by liquid, that is force of buoyancy, that is weight of the liquid displaced, mlg, which is usually equal to mass means volume into density of liquid, that is VL rho Lg. ml means VL into rho L. Why? Because mass equal volume into density. See here, VL means volume of the liquid displaced. So volume of liquid displaced further. See, volume means that is minus volume, area into length. So what is the cross section here? A. So area into length means what? Not total length, but additional dipped portion. See the length of additional dipped portion, that is A into Y. So volume, area into length. Length means we should not consider total length of the object. So whatever the amount, whatever the distance, it is further submerged, that only will be taken. That is area into additional dipped length into density of the liquid into G. Right? Now Fr means usually minus k into x, otherwise minus k into y. Here it is symbol y is taken, that's why I take Fr as minus k into y. So minus cancel, y cancel, we left with k equal to a rho Lg. Now what is k? Usually equal to m omega square. M omega square. That is omega square equal to a rho Lg by m. Omega equal to root over a rho Lg by m. Usually omega equal to angular frequency equal to 2 pi by t. 2 pi by capital T. Now t equal to 2 pi into root over m by a rho Lg. So this is the ultimate expression for oscillation, period of oscillation of floating body in the liquid. Okay friends, with this I'm concluding. So thanks for watching. Stay tuned to Sea Level Physics. Bye.